Ciao friends, and welcome to a new Unplugged video from SQL BI. In this video, I want to further elaborate on an answer that we already provide to a question about skills and levels. Laura sent a question to GENERATE about a data model that is useful to decide whether a candidate is fit for a specific job based on skills and levels. We already provided the answer during the live with GENERATE, but then we didn't have time to elaborate on the topic and to show the entire process of writing the code. And there are a couple of reasons why I wanted to record this video. First of all, and to me the most important detail, is that the question asked by Laura was just perfect. Laura provided us with a set of data, very small set of data that was clear in indicating where the problem in her formula was. We already had the answers to search for, so it was a very well asked question. And then the model in itself is interesting because there are different ways of solving the same scenario. So what I did after answering during the live, I just removed entirely the solution. I tried not to look at that, so during the Unplugged video we will start from scratch and we will elaborate on the solution, finding what we can about Laura's questions. But first I need to explain you the question in itself, and to do that we jump to the computer and we start looking at the data model. Let's do that. Now, this is the model that Laura sent us, but before I want to show you the visual, the report that she sent us. The report contains all the visuals that are needed in order to understand the question, a report with her proposed solution, and a text box that contains a description of where she is facing problems, so we have a clear indication of what to search for. Besides, she already provides the answers to the questions, and that again is extremely important. It saves us from searching for the numbers. She already computed them. But let's talk about the scenario. The scenario is about finding whether a candidate is fit or not for a specific job. I have the model here, but I actually have it also in the whiteboard, so we can reason there. So we have jobs requirements, and this is in the jobs table, and each job has specific requirements. So the job requirement table has the job ID, and not this one, this has the job ID and the level. Level is going to be important. So in order to apply for a job, you need to have a specific skill and a specific level. The skills are in the skills table, so this is a many-to-many relationship between jobs and skills. Then we do have employees. Let's use a different color, like blue. We have the employees table and we have the employee skills. Again, we have another M2M many-to-many table that you cannot read, so let's clear that. We have another many-to-many relationship between employees and skills. So this model contains two many-to-many relationships, and the task is given an employee and a job to check whether the employee has all the necessary skills in order to apply for the job. Level is important because, let me clear everything. Okay. Level is important because we have the level here and we also have the level here. And a candidate can apply for a job if it has at least the required level. It can have a higher level and that would be good, but it needs to have at least the required level. Now, with all that said, we can start playing with the code. And before going further, I want to show you already Laura's solution because she already computed some numbers. She did not take into account the level. She just worried about whether the candidates has the necessary skills. And her code is already working, but I checked it already, and there are some details that I want to discuss further. So we have the matching skills calculation. And this is her original solution. How does it work? Well, first, let me see if we can place everything in the same screen. Yep. Here we are filtering by employee name, and by using a slicer, we select like clever report person. Now, a clever reports person needs to have DAX at level 2, M at level 2, and visualization at level 1. These are the skills required to be a clever report person. What is the evaluation for Chris? Well, if we focus on Chris, Chris has DAX, M, and visualization, therefore is a good candidate, and all the levels are higher, but she did not care about levels. Whereas Bob has only visualization, so it's lacking both DAX and M, therefore its evaluation is 33%. It's not 100%, it is missing some skills. How does her code works? Let's go to the code to understand it. First, it gathers the job requirements skill ID. Now, job requirements is here. Again, we need to clear everything. This is job requirements. So from here, she gathers the skills ID, and it retrieves only the skills ID. Then she counts the number of skills that are required, again by using job requirement skill ID. And then it needs to compute whether the employee has the skills. We have the employee skills table. Now, the employee skills table is this table, which is being filtered by the employee. So Chris is filtering the employee skills table. Therefore, by counting the number of skills which happen to be here, we can check whether the number of skills that this guy has. But we need to apply a further filter. We are not interested in all the skills of this guy. We're only interested in the skills that match with the skills required. So she uses 3 tasks to change the data lineage from job requirement skill ID to employee skills ID. And these 3 tasks is needed in order to move the filter the right way. Again, where's my dashboard? So we want the filter to go from job requirement to employee skills. And to do that, she uses 3 tasks. Which is fine. There is nothing wrong with that. But I think we can do slightly better than that, because 3 tasks is good, but it's not the fastest function, and it's not the best way to move a filter from one table to another. If we had the option of using relationship, that would be way better. So I want to rewrite it. Actually, I don't want to entirely rewrite it. I just want to create a new one so we can check that the numbers are correct. Let's call it matching skills 2. We format it as a percentage. She does not use decimal places, and we place it here just to check that the numbers are still the same. Now, what can we do better? By using values, Laura is retrieving from the job request tables, from this table. But actually, the matching table, the table that acts as a real bridge between the 2 bridges, is in the skill table. So jobs, because of the slicer, is filtering job request, and job request has a many-to-one relationship with skills. So we can use summarize to group job requests directly by skill ID from the skills table. And why are we doing that? Because skills will be able to filter employee skills along with employees in order to find whether there is a matching or not without using 3 tasks. So a different way of obtaining the same result is not to use values, but to use summarize. And we summarize job request by skills ID. We can do that because of the relationship between the 2, and this is going to be solved by storage engine. So now we have the skills ID which are computed here, and we are using count. Now count is again counting the job request from there, but we can actually compute the count on top of the variable that we already computed. We already have the set. We cannot use count, we need to use count rows. And the advantage of having in skill request a table that is already a skills ID is that we can use skill requested directly here. Skill requested will filter the employee skills table because of the one-to-many relationship, and it already has the correct lineage because it's a skill ID. So by computing it this way, we still have the same number, and this is not necessarily better, but it's a lot more DAX, and it does not involve the usage of 3 tasks. So by leveraging relationship, we obtain code that is slightly better. With all that said, we are not using relationships here. So we are not using the level. Right now, the calculation is only taking into account the skill set. So the candidate needs to have the correct skill set. But what about the level? In order to handle the level 2, we need to completely change this code. And Laura already notices that. If we zoom in a bit, you see that there is the explanation about what she did, but she needs levels to be included. So for Data Basher, Chris and Alice right now shows 100%. Let me show you that for Data Basher, both Alice and Chris, they show 100%. The thing is, if we look at Alice, Alice has M, video editing and visualization all at level 1, and M is required at level 2. So Alice actually should not be a match to 100% because M, she has it only at level 2. And that's what she is saying. Alice has only 1, so she should get 0%. Chris has level 3. Chris has level 3 for M, therefore it's more than 2 and it's 100%. And right now, this calculation is not taking this into account. So we need to solve that. And solving it requires a completely different approach, even though the idea is close to what she has done. We will start from job. Job filters the job request through the slicer that we have here. Job request contains the level, and skills contains the skill ID. The problem is that skill ID will filter employee skills, which is again filtered by employees because of the visual. And we will need to compare this level with this level when they have a matching skill. That is gonna be a bit more complex. What we can do is first gather a table that contains the level and the skill ID, and then use this table to check whether employee skills contains a row where the skill ID is the same as the skill ID and the level is at least the same level. And that can be done. So we can create a third measure. Well, actually, we can change this measure. And we get rid of everything because we are using again summarize, but this time we do not retrieve only the skill ID. We also retrieve the job requirement level, job requirements level. So we obtain a table that contains the skill ID and the level. And then we need to use this table. Let's create another table that contains... no, we don't need another table. We can just create a new variable, valid skills, where we filter. What do we filter? We filter the employee skills table. And we search for rows where employee skills skill ID is Well, that's not that easy. We can check whether, that's interesting. We can check whether, let me see, it's not that easy. We cannot filter directly employee skills because we cannot check whether there is a row. The row needs to be greater than. So what we can do is filter employee skills. And for each row of employee skills, we count if the skills required contains rows where the skill ID is employee skills ID is identical to job request. No, to skill ID. Skills ID, because skills ID is in the current row context because we are iterating skill request that contains the skill ID. And at the same time, the employee skills level is greater or equal the job request level. So the valid skills, the skills in employee skills that are useful to evaluate this guy are the rows in employee skills that are useful to evaluate this guy. So they need to match the level, the skill ID, and the level. And then the result is just the division of count rows of valid skills divided by count rows of skills request. And then we return the result. That might work, I have no idea. We can check that, and it's already promising because it shows 100% for Chris and nothing for Alice, because Alice has M at level 2, whereas Chris has M at level 3, so that's already working. Let's see for clever report person. For clever report person, Alice should be 33%. Alice should be 33%. Why that? A clever report person needs to have DAX and visualization, and Alice has DAX. Alice has M and visualization. Visualization at level 1, DAX, she doesn't have it, and M, she has it at level 1. So M does not count. Visualization count, that's 1 out of 3, and it shows 33%. So this version is working already. And it's kind of fine. The only problem is that we have a filter, another filter, so we have 2 iterations that are likely to use quite a lot of Formula Engine to run. So it's not bad, it's already a good solution, but I'm totally not sure that it is the best solution. Besides, I have a different idea in mind that I want to play with. And this goes back, by the way, that is mainly for Laura and for the people who watched the live with GYNACube, because in the solution that I provided with GYNACube, I used the generate function, which is a function that I totally love. Few people use it, but it's really, really powerful. And that solution, the solution we proposed, was using generate. The reason is I started with an idea, I started using generate, but then during the process of writing, I didn't use actually generate, I used a completely different pattern. Therefore, the code that I was showing during the live was using generate for no purpose. In the code we have since right now, we are not using generate at all. And the reason why I was using generate is because the original idea that I did not develop at the time was completely different. The idea that I had in mind is to build a set that can be intersected with the required set. So the skills required contains the required skill, so M at level 2, for example. M at level 2 cannot be directly intersected with the skills of the employee, because the employee might have M at level 3. So the row M2 does not intersect with M3. It will not match, even though I want that to be a match. So the idea that I had in mind is, well, I have the required skills, and I build based on, I save this set. I build another set that contains all the skills of the employees that can match the required skills. So if an employee has M at level 3, I build a table that contains M1, M2, M3. So that a table with M1, 2, 3 can be intersected with M2 and produce one that is a match. So what I want to do is build a table starting from the employee skills that contains all the skills at the existing level or below, so that I will use intersect to intersect the two. And we can do that using generate. Let me show you this. We can do it from here, but it's likely it's easier if we go for DAX Studio. So let me copy everything, and let's take Alice. Alice is a good example. I want to build for Alice. No, Alice is not actually a good example. Let's see, Chris. Chris has everything at level 3, and the requirement is 2 to 1. So if I try to intersect the set of, so if I try to intersect this set with this set, that is going to fail. It's not going to work. So what I need to do is build a set that contains DAX 3 to 1, M 3 to 1, video editing 3 to 1, so that I build a larger set that can be intersected with this smaller set. And it will provide that, it will tell me that Chris is actually a perfect match. To do that, we need DAX Studio. So we go for DAX Studio, which opens in a different monitor. And we use generate. So I want to start from employee skills. Employee skills. And that returns the employee ID, the skill ID, and the level. But I want to filter only Chris. So we place a filter on the employees for the name, which is equal to Chris. Control F6. So this is telling me that this employee has this skill ID at this level. Actually, I want to have summarize employee skills by skills name. And I also want the employee skills level, because that is much more readable. Let me get rid of this so we have a bit more space. We will probably need it. So now this is the set of skills for Chris. Everything is at level 3. Now the thing is, I don't want just 3. For each skill, I want 3 to 1. So what I need to do is add further rows to it. And for each level, I want all the levels starting from 3 and going below. I need a table that contains 1, 2, 3, all the possible levels that exist. So one option is to use a cross join. I could cross join this with all no blank row, and where can I grab the levels from? Employee skills levels. Because I'm using cross join, that will return all the possible levels. No, actually it generates an error. Yes, I need to rename this. So let's rename this as select columns from this level. What's wrong with you? Cross join, summarize, select columns. Oh, that comma is wrong. Okay, now by using cross join, I generated everything, but I'm not actually computing the values correctly because I'm not filtering the case where somebody has a lower level. By the way, Chris is probably not the best example. So let me see if I have Alice, Bob. Well, Bob is actually a good match. Bob matches both 2 and 1. So if I go here and I use Bob, you see that Bob has level 2, but I generate all the possible levels. So if I want to filter out the ones that are not important, I can use a filter around everything and retrieve out of the cross join only the rows where the employee skills level is greater or equal the level. Let's format it. Control F6. Okay, you see that the code starts to be a bit more complex and it doesn't work. Level does not exist because there are multiple columns named level. I should use a different name. I should have done this from the very beginning. Now, because Bob has level 2, I only see level 1 and 2. And this table contains both visualization 1 and visualization 2, so that can be intersected with my result. The problem is that this code is kind of complex. What I can do is make it simpler. Instead of using filter, I can use generate. For each employee skills and level, so this generates only a table containing skills and level, I retrieve a table that contains a filter out of all the possible levels, where the employee skills is greater than the level. And if I did it correctly, that should still work. If I run it, you see it produces the very same result, but generate will not perform the full cross join. It generates a smaller table, so it's going to be slightly faster. Now I have a table that contains all the possible requirements that Bob satisfy. And if I go for Chris, of course, I will have level 1, 2, and 3. So I need this part, the generate part, that contains the skills which are valid, the skills that can be used to be intersected with the requirement. And this table contains the skill name, the level, and this column at level. I don't want this column, I just want this column to be renamed level. So out of all these, I put a select columns around everything, and I grab the skill name, which is skill name, and I grab the level, which is the level, with the at before it. So I have the skill name and I have the level. Skill name has the data lineage of a skill name. Level has no lineage. That might be an issue later. I'm gonna discover that in a while. But this code generates the table that I want. Now I can use it in my measure. I actually need a third measure. Let's call it ms3, where I create a variable. Let's call it let's call it available skills, where I store the same table that I was computing in the other place. Then I need the required skills. And to do that, I use summarize from the job requirement, summarize the job requirements by skill name and level. Where is my level? I don't see it, but if I write job request level. So required skill contains the skill name and the level. And then good skills, I can use intersect, and I intersect the job of the required skills with the available skills. And good skills should contain only the skills which are valid. And then I divide count rows of good skills by count rows of required skills. That might work. I have honestly no idea. That's the beauty of writing Unplugged. MS3, it's a percentage, get rid of decimals. Let's place it here. It's working. That's amazing. It's working the same way as MS2 for clever report person. What about awesome YouTuber? Same value. Data basher? Same value. And MS3, it looks really different and much worse than the previous one. But I'm not honestly sure that it is, because Generate is going to be very well optimized. And the intersect is the last operation that is computed. Besides, it has the advantage that it computes some value also at the grand total, which might be different. Yeah, you see that MS2 provides this strange 167% of the grand total, because it's summing individual values, which is kind of weird. I know it doesn't make sense to show a total because we are evaluating person by person, but this is a meaningful number, because this is saying, well, considering Chris, Alice and Bob together as a team, they cover 100%. Individually, they have fewer skills, but if you hire all of them together, you are able to cover 100%, whereas this number, 167, doesn't mean anything. So this new measure has some value, and it might be worth evaluating further. Besides, it can probably be optimized a bit better. We could evaluate performance, but the thing is, with the table, with only three rows or just a bunch of rows, it would be really hard to evaluate performance. Besides, both MS2, because of this double filter, is probably going to use a lot of Formula Engine. And MS3, again, is going to use a lot of Formula Engine because of this intersect. All this part can be actually solved entirely in Storage Engine. We do not use Formula Engine to compute available skills, but then intersect for sure will require Formula Engine. Which one is best? Hard to tell. Here my goal was not evaluating performance, it's just showing the flow of thinking in finding different solutions, and also introduce the reason why Generate was useful. Generate makes it simpler to reduce the cross join that we had to write using the previous code with DAX Studio. Okay, I don't think it's worth going further on the topic. We have seen a couple of scenarios. So as you have seen, when you start thinking at a solution, you have different options. In this specific scenario, tree task was not needed because the chain of relationship is so well designed that you can rely on physical relationship and use them by using summarize. Remember that summarize is totally bad in computing values. Summarize is a complex function if you make it compute values, but if you use it group by, you can group a table by any table that can be reached through a relationship, which is very, very good. So by using summarize the right way, we have been able to build tables that move filters the right way. That was the first thing that we did with Laura's code. Then we changed it a bit by using a couple of filters in order to include also the level. And then we went for a more fancy solution, much more DAX, if you ask me, but I don't know if it's faster, that builds the two sets, the set of required skills, the set of present skills, and then intersect them in order to build the final result. The interesting part was using first cross-join and finally generate to build out of a table that contains only the highest available level or the levels for which this level is actually good for. Different ways of writing the same code, and interesting to investigate to learn more about DAX. Enjoy DAX!